Welcome to Energy Talks, a regular podcast series with expert discussions on topics related to power system testing, data management, and cybersecurity in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. In this episode, which is part 7 of our mini-series called Cybersecurity in the Power Grid, we will learn how an OMICRON team of cybersecurity experts goes about analyzing incoming alarms and how even the smallest indicators can reveal hidden dangers that threaten the safety and operations of an entire system. This was put to the test with the Norwegian utility company, Glitranet. They conducted an intrusion detection system evaluation exercise at a live substation to compare the solutions of multiple intrusion detection system vendors, including OMICRON. The project involved executing live attack simulations in the substation to compare the detection mechanisms of the solutions. Glitranet also wanted to ensure the detection response and support capabilities of the cybersecurity experts at each of the vendor companies. 3 OMICRON cybersecurity experts joined me in this episode to describe their involvement in the project with Glitranet and how they successfully completed it using OMICRON StationGuard intrusion detection system. Let me introduce them to you. First of all, we have Ozan Dayanc. He is the technical product manager for OMICRON StationGuard and GridOps Solutions. Ozan has been a guest before on Energy Talks. Welcome back, Ozan.
Hi, Scott. Nice to hear you again.
My next guest is Christoph Rheinberger. He is an OMICRON cybersecurity analyst who has also been a guest on Energy Talks. Thank you for joining me again, Christoph.
Hello. Nice to be here again.
And my third guest is Lukas Schneider. He is a full-stack developer in the OMICRON cybersecurity team. Lukas, welcome to Energy Talks.
Hey, thank you.
Well, great. I would like to get deeper into this topic. Ozan, maybe you can describe the complete situation here. Why did Glitranet approach OMICRON for this attack simulation test?
Yeah, before I answer that question, maybe a little bit of information about Glitranet. Glitranet is one of the biggest electricity distribution system operator in Norway. They provide electricity to almost 350,000 people. And Glitranet was already an OMICRON customer by our other business units. So They knew us, we knew them. And as you know, OMICRON specialize in power grid environments, in primary, secondary, and in the networks as well. And this project sounded really innovative. And you know how OMICRON likes to be involved into the innovative projects. So therefore, we were up for it. And they were also confident that we were the right candidates for this project.
What was the real purpose behind this test?
Yeah, that's a good question. The purpose behind this test is basically regarding securing the substation automation systems, which are the critical infrastructures for this DSOs, distribution system operators. And in order to secure these environments, there are certain steps needs to be taken, and monitoring is just one of these steps. And they wanted to find the right monitoring solution, or it's also called intrusion detection system solution, for their critical infrastructure. And therefore, they wanted to start an evaluation project to find the best solution that fits for this environment. And that's how they were out there with this project, looking for the idea solutions, inviting the vendors into this attack simulation test. That's more or less how everything started.
Very good. Okay. Well, thank you for that explanation. So can someone explain the test setup to me? How did you initially receive the data?
Yeah, sure. I will take the question. So our sensor was sitting in a live substation and gathering the data. Also during the conduction of these attacks. So after the attacks were done, we got the configuration files for StationGuard, the event logs, and also all the PCAPs that were created on our system to analyze what happened. So either we could use the direct access to the installation on site or a local replica on our system. And every additional information regarding the collected data we needed was provided on demand during this evaluation.
How can attackers infiltrate systems, and who are they targeting?
Right, I will take that question. First of all, we have to look at the profiles of these attackers to understand the reasons behind these attacks. When it comes to there, we have these 3 different profiles. There are script kiddies, which are more or less like the amateurs. They're trying to learn stuff by trying out new scripts and attacks. And these are usually the harmless ones, but they can potentially be evolved into something more dangerous. And then we have these professionals, which are doing this to earn money. So with all these ransomware attacks, where there's no political reasons behind, for example. And then the most dangerous ones, which are the state actors, those are the ones behind the most sophisticated attacks. Yeah. So these are more or less the 3 profile that we are coming across when it comes to the attackers. Yeah. Christoph, would you like to make an add-on here?
Yeah, I mean, about who are the targeting. So in our case, we look at the whole OT environment and critical infrastructure, of course. So yes, they're targeting critical infrastructure. I mean, it always depends on who you're talking about. But for us, it's always important to keep it to the critical infrastructure. That's the area we are proficient in. And yeah, so to get back to the whole point of the attack scenarios that were conducted, to get there, an attacker would have some different kinds of intrusion, ways of intrusion, like physical intrusion, just getting in there, like remote connections that can be abused, portable devices that are just dropped on the premises and plugged in by an unknowledgeable or uncareful employee, or just device vulnerabilities themselves you could abuse, or also just the equipment that a normal employee would bring into the substation for day-to-day use, like testing equipment and engineering notebooks. So there's many ways to get into one of these systems. But yeah, back to the actual task at hand with the GlittreNet simulations. Ozan, so you organized the whole project from our side. So could you provide some insights on how they approached this simulation of the attacks?
Yeah, sure. When I was listening I already heard some of those attack vectors that has been used in this project. So yeah, these are really the ones that are commonly targeted, as we have also seen in our case. So coming back to our project, actually this was really a unique approach by GlittreNet, right? I mean, the attack simulation was conducted in a live substation. I've never seen this. I have been traveling around between utilities all around the world, and there were not such an approach that I have come across before. And there were these 3 IDS vendors. One of them is ours, StationGuard, that has been participating into this project. And the idea was to find the best solution out of this attack simulation project. And the GlittreNet basically conducted the attacks together with their service provider into this live system. But of course, they did a very sophisticated attacks in order not to interrupt the operations. So they didn't want to have many operations there. It was quite dangerous. And after the attack, each vendor got access to their system to analyze it, like how you gave the explanations, the details, Christoph, and to find the solutions that promises less effort for a rollout between the substations. Also, as a tailor-made solution, they have conducted these attacks and made an evaluation out of it. And they didn't want to evaluate only the IDS systems, but they also wanted to see the capabilities of the team behind each one of these IDS systems. So they were also focusing on the incident response side of the story, not just the detection. Yeah, these were more or less how was the GlittreNet approach. But by the way, Christoph, it also makes sense to mention who makes up our cybersecurity team in OMICRON, because that's where the most value is, right?
Yes. So I will follow the same approach that we had beforehand. So I'll start with the OT engineers and the people knowledgeable in the 6150 and, for example, our 104 protocols, because those people provide us, like, for example, me and the other cybersecurity analysts with all the required knowledge we would have to make decisions on incidents or alerts in these kind of systems. And additionally, from the other side, we also have, like, for example, Lukas, who can help us from the development of the device and also with their knowledge about how we dissect, for example, or we detect these kind of things. So we just have a very, very broad knowledge base. We can just tap into if we need to or when we need to. So that's actually a great point here as well. And additionally to the people behind it, it would also make sense to talk about the tools we used. So Lukas, do you want to jump in here?
Sure. So for this simulation, we used two of our products. One is StationGuard, which provides a clear and precise information about the system's status and any security events. This clarity is very crucial for quick decision-making and effective response to incidents. And moreover, we used StationGuard Central Management, GridOps, which is an absolute game changer. It allows analysts to efficiently analyze and mark incidents. This centralized approach means that insights and data are easily accessible and streamlining the process of incident management and reducing response times even more. As Christoph already said, together, our team of experts and our solutions create a powerful setup to effectively and accurately react to incidents like in this attack simulation.
I mean, I've seen how you guys distributed the tasks and how you allocated the responsibilities. I think this played also quite a crucial role in this project, right? This planning of things. Lukas, you were there as well as with Christoph. Maybe you can extend that a little bit.
Sure. So first we created a clone of the customer's system using backups and configuration files they provided, as you two already mentioned. This allowed us to be very flexible and work with our tools like our customers would. Next, we organized the collected events into specific areas that seemed most interesting using GridOps. This helped us to systematically identify different types of potential attacks, categorizing them by patterns and anomalies. Simultaneously, we conducted preliminary checks for any obvious indicators, such as the presence of unknown devices connected to the network. This initial scan allowed us to quickly address the most apparent attacks, such as TCP or UDP port scans, and man-in-the-middle attacks through ARP poisoning. Finally, after our rough initial analysis, we shifted our focus to more puzzling incidences. These required deeper investigation as they were less straightforward and often involved complex scenarios that weren't immediately clear from the onset.
So yes, I'm gonna jump in here again. So we had also to utilize the knowledge of the different experts here again, because there were issues like I couldn't straight away just identify. So for example, some functional issues in the substation that were maybe triggered by some interaction with them, like unprovoked or provoked. And for that, we just reached out to our experts again for the 6150, for example. So there were issues like unsuccessful control commands or timed out requests. There were interactions, also MMS interactions that were not permitted, like the HMI reading values and writing to control blocks while the system was not in maintenance mode, for example. And additionally to these things, there were also more like direct attacks. Like, for example, there has been quite some reconnaissance being done in the substation during these simulations, like UDP trace routes, ping sweeps, port scans, all these kind of things. And the most interesting part for this kind of like reconnaissance was that, for example, you could also see that their system was actually set up quite well, and the network devices wouldn't allow these kind of like reconnaissance just right away. And they would have to reconfigure the devices first to disable, for example, security measures, and afterwards enable them again. So these kind of attacks wouldn't be possible anymore. And one other big like incident or attack that was performed was that they actually just replaced one of the physical devices with an identical clone of that device. And we actually managed to figure that one out as well. So what happened there, just gonna summarize it quickly. We had two areas where the device wasn't sending any data, 2 timeframes. And in between, there were quite some, well, how to say, suspicious activity, let's phrase it that way. So there was, like, for example, right after reconnection of the device, there was a so-called gracious ARP, which just means that the device just tried to figure out if its IP address is still open or valid, and just like broadcast that out into the network. And that was in combination with the fact that it was a so-called automatic private IP address, which means someone had connected the DHCP server, or just the device tried to connect to the DHCP server while it wasn't connected to the substation. And with all these like hints and things, we just thought that someone replaced the device, which was actually also what really happened. And additionally to that, this compromised device attempted to start like do reconnaissance, like ping sweeping, trying to connect to web servers in a network. And of course, everything else the server did, like other MMS connections, like these 6150 connections, should also be just taken with a grain of salt afterwards, because we know at this point the device is compromised, for example. And of course, these two weren't the only ones. Attacks we also took a look at. There were many more. We all wrote them into the report. There were, like Lukas already said, this very glaring ARP poisoning during the whole time. Then functional problems again, like disappearing goose messages when a device was disconnected or just denied. There were net bias reconnaissance, and as well as, for example, an RDP brute force to try to get into a remote host with the protocol of RDP. And additionally to all of these like attacks we analyzed, there was in the background, we did asset vulnerability matching, or the system did on its own, but that evaluation wasn't part of the scope of the project. But now taking a look at the whole report, and with all these incidents we added to the report, we actually reached pretty much every goal with a 99% success rate overall. So
that is true. But it's worth mentioning here, right? The main tool that helped us detecting all these problems was StationGuard. So StationGuard detected all these attacks, and rest of it was just analyzing and trying to dig in a bit more into the details and bringing out what is hidden there. So our solution did help us a lot during this analysis.
yes.
And that is obvious. I must also say that Giltranet did a very sophisticated tests, including all these different type of attacks. So it was also a really good exercise for us when it comes to the team, right? And at the end of the day, as you mentioned, Christoph, we have detected 99% of these attacks and delivered them a report on a timeline on when these attacks were happened. And of course, it gave confidence to the Giltranet for working with our products as a main outcome out of this project, and also our team, because our team was there delivering the report, explaining about each attacks and showing how deep we went into these incidents. And it once again proved the intelligence of our solution, as it was the main source of detection system. And another important point here is that the collaboration between the IT and OT, right? This is more or less our motto, to bring these two domains together when it comes to the securing OT environments. Because the IT has the knowledge of cybersecurity. They have been implementing this for a long time, and OT has the knowledge of the environment. And because we have leveraged this knowledge, both domains, at the end of the day, it helped us detecting most of these problems and analyzing them.
Well, thank you all for that interesting description and discussion. It surely isn't easy for solution providers like Omicron to continuously react to this variety of attack possibilities, but this is why we continue to improve our products and solutions. Am I right?
You're absolutely right. We can say that we are in an era of agile development, right? The digitalization is everywhere. We can see it in the substations, control centers, critical infrastructures, and market is too dynamic. Requirements are keep changing because it's more or less like an accelerated development. And the regional requirements between continents, for example, makes it even harder because Yeah, the requirements are similar to each other, but there could be slight changes between, for example, European security requirements and American security requirements. But at the same time, these market requirements and regulations helps us through the development because they are more or less like a guidance. And we observe these changes carefully and track the customer requirements and then combine all this knowledge, all this feedback, and implement them into our solution. And of course, the main challenge here, or let's say what plays the most crucial role, is the prioritization, because that gives us the momentum implementing all these requirements. For example, out of this exercise, there was a missing 1% of the attacks, right? We keep saying 99%. And this was due to a minor router behavior issue at our solution. And this was really a minor thing. And then we have improved that immediately and implemented into the StationGuard. So that's why it was really a good exercise for us. There was a lot of takeaways from our side as well. So if we would participate in this attack simulation again, we would probably detect 100% of these attacks that has been conducted by the system owner. And for the future, of course, we have a lot of plans. We want to improve, for example, if I want to go into the details, we want to improve our signature-based detection, visibility in the network, maybe more functional security features. Maybe another important topic is to mention here is improving the asset inventory collection, where we want to improve in our product. Because asset inventory collection is a topic almost in every customer that we visit. Also, it is worth mentioning, this valuable exercise again improved our knowledge in the field of incident response. These are more or less our plans, Scott.
Very good. Well, thank you for that summary. Is there anything else that anybody wants to mention before we say goodbye?
Yes, I have one last message. The OT security monitoring is a very important topic and becoming a very hot topic especially for the power grid environments. It is very important that the solutions that are provided into these environments needs to be tailor-made solutions that is focusing on specific domains. That's the first takeaway I want our audience to have. And the second thing is that the IT and OT collaboration is quite important when it comes to the incident response in these kind of environments. And if you have a solution that IT and OT team can work together with, that's even an additional advantage. And that's what we are promising in OMICRON with our solution StationGuard and with our experts in the team.
Very good. Well, Ozan, Christoph, and Lukas, thank you very much for joining me for this episode of Energy Talks, for this interesting discussion about the exercise with the utility company in Norway.
Thank you very much, Scott. This was really fun for me.
Thank you.
Thank you for having us.
Great. Well, thank you all. And a big thank you to our audience for listening to this episode of Energy Talks. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity in the power industry, and offers you the matching solution for your application. For more information, be sure to visit our website at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.